Guys, welcome to this question now. Examples. Okay, examples. So the question says a compound with a known molecular weight of that value that contains only carbon, hydrogen, and chlorine. Now, where there's chlorine, I am going to erase that. I'm going to use oxygen. So here we use oxygen instead of chlorine. Yeah, of course you can use chlorine, but in this case we won't use the chlorine. Yeah, there's a typing error there, so it should carbon, hydrogen, and oxygen. Why not chlorine? Because we know that at the end of the day, what should be on the reactant must be on the product side. So we can't have chlorine in the compound, and on the product we do not have any chlorine. So we are going to use oxygen there. We'll still answer the question. So a compound with a known molecular weight of that value that contains only carbon, hydrogen, and oxygen was studied by combustion analysis. We understand what combustion analysis is by now, just a technique that we use to find the elemental composition of the compound. What elements constitute that particular compound, by measuring the products that have been formed. So when a 0.367 grams sample was combusted, you understand, so they measured the mass of that particular compound, and they also had to measure the carbon dioxide that was produced, and that is the mass, and even for H2O, that was the mass. The question was what are the empirical and molecular formulas? Okay, let's do this. So this is what we are going to do. We are going to find, so steps, we are going to say finding the individual masses. So we are going to find the masses, or if you want, you can find the percentages. It's okay, because I said when they ask about the empirical formula, you can have the masses or the percentages, but either of the two, it's okay. So I'm going to find the masses of carbon, hydrogen, and oxygen. And let's start. Let's find the mass of carbon. So for mass of carbon, I'll say MC. So mass of carbon is equal to what? Guys, in class we learned what is percentage composition. So we are going to say it's the molar mass of carbon in carbon dioxide. Remember I said the mass of carbon comes from carbon dioxide. So we are going to divide this one by the mixture of, or the molar mass of CO2, then multiply by what's the mass of carbon dioxide, the total mass of the compound, which is carbon dioxide. So what we're going to have, which is 0.659 grams. We know that when you get the mass of carbon in carbon dioxide, carbon dioxide is written like that. We know that the mixture of carbon is going to be 12.01 in carbon dioxide, then divide by the mixture of carbon dioxide. If you calculate it, it will be 44.01 if not mistaken. Then multiply this by 0.659 grams. So what becomes the answer? So this means that we are going to multiply, open my calculator. So if you multiply 12.01, I divide, whether like it or not, you're going to find these questions in your test. And we multiply it, so 0.1, then we multiply it by 0.659. So I'm getting the answer approximately to 0.179 grams. So this is the mass of carbon. I'm going to write it somewhere. So carbon, the mass is about 0.179 grams. Okay, I'm done with the mass of carbon. So I have to find now the mass of hydrogen. The mass of hydrogen, what did I say in that other video? I said the mass of hydrogen comes from the total mass of H2O. This is what they analyze in their labs. All right, they apply this one. So in this case, I'm saying it is the mass of hydrogen, right? Then divide the mass of H2O. Then we are multiplying by the total mass of H2O, since I'm concerned more about hydrogen, which is coming from H2O. So I'm going to use the mass of water, which is 0.0892 grams. Okay, so the mist of water in hydrogen, we have two in hydrogen, we have which is H2O, so we have two of them. So 2 multiplied by 1.01 becomes 2.01. Then divide this by the mist of water, it's about 18.0 if not mistaken, 1. Then multiply by this mass, 0.0892 grams. What becomes the answer? Let me use the calculator here. So we have 2.01 and we are dividing 18.01 then by 18.01, then we are multiplying by 0.0892. So approximately I am getting the answer to be 0.00995 grams. So that becomes the mass of hydrogen alone. So this means that I have the mass of carbon and I have the mass of hydrogen now. So I have the mass of hydrogen as well, which is about 0.00995 grams. Makes sense. Now the question is, what am I remaining with? I have to find the mass of oxygen. Right, so what's remaining now is, remember they said this compound contains carbon. It has carbon, it has hydrogen, it has oxygen, okay? And the total mass of this compound is what? 0.367 grams. And one thing, guys, is that when you've been given these masses, okay, always you have to have them in grams. When they're not in grams, it means that you have to convert them yourself in grams. So let's find the mass of oxygen. It's easier. You know the mass of carbon, you know the mass of hydrogen, and what about oxygen? So for the mass of oxygen, you come and say it means that mass of carbon plus mass of hydrogen, you have to show all this work, plus mass of oxygen, what's the total? Is 0.367 grams. So let's add. This means that mass of oxygen is equal to 0.367 minus the masses of those, which is 0.1798 minus 0.00995 grams. So let me do the computation here and see what answer we're going to have. So 0.367 minus 0.1798 minus 0.00995. If not mistaken, 0.179. Then what's here? Let's see, 0.367. Okay, so I am getting something like 0.177 2. I don't know if this is correct, but something like this. Once we make a mistake here, everything becomes wrong. So grams. So what do we have here, guys? We have the masses now. So the mass of oxygen is about 0.177 24 grams. Something similar to that. I may make some errors, but you can correct them. Okay. Now the question is, you have to find the empirical formula. So what all we're doing, we have to find the masses of this. It's the wrong process, guys. So let's go. We have the masses now. So let's arrange these, guys. So we say, let's arrange them in this way. The mass of carbon is 0.1798 grams. Then what about hydrogen? Hydrogen is about 0.00995 grams. Then oxygen is about 0.177 and 24 grams. Right, what's the step? we have to divide this now by their molar masses, 12.01. Even here we divide by 1.01. Then here we divide by 16. Let's find out what are the ratios, what numbers are we going to get. Okay, so 0.1798, you divide this by 12.01. We're going to have something like 0.014970. Okay, then the next one we're going to have 0.009955 and divide by 1.01. So this gives us something like 0.009856. That's there. It's okay. And it's new, guys, so people are playing. This is amazing. Celebrating the new year. Divide by 16, so it's giving me 0.0110077. Okay, at this stage now we have to divide by the smallest. Which one is the smallest here? 0000. So 001. So is it for this one? So it's the smallest, if not mistaken. So let's divide this 0.009856, and this is 0.009856. Both throughout. You check out the smallest. Yeah, so this is the smallest, if not mistaken. Yeah, this is 0.009856. Let's see the ratios that we are going to obtain upon dividing. So the first one, we have 0.0149708 divide 0.00986. So the top one we're having 1.2 decimal places, 1.5, 1.52. Okay. Then the next one, I think this is 1.00, and let me divide the last. This is 0.011 077 divide 0.009856. So this is giving me 1.12 to 2 decimal places. So at this point, what did I say in the videos? Round off now to 1 decimal place. Okay, so to 1 decimal place, what becomes the values? What becomes the values? So becomes the values, guys. Okay, so for carbon that becomes 1.5. Then for that one it becomes 1.0. The other one becomes 1.1.1. How do you round off? So this, if you round this one off, becomes 1. Remember, if it's raised or equal to x.2, then it becomes 1 as well. But you can't round off this one. What do? Find the factor. In this case, the suitable factor is what? Is 2. So multiply this by 2. Multiply this by 2. Multiply this by 2. This becomes what? A 3. And this becomes what? A 2. And this becomes what? A 2. So I have the empirical formula now, guys. Very amazing, very simple. It becomes that C3H2, and we have O2. So this is the empirical formula, guys. How do you determine the molecular formula? You're going to do that. So your work is to determine the molecular formula, then you're good to go. You're done with the work. So watch the videos. Please practice as many questions as possible. So your next question is, I want you to do the molecular formula, guys. Thank you so much. God bless you.